Hey, year sixers in the house! How are we getting on at home? Right, this is the first video that we're going to post, so let's see how it goes. I know quite a few of you are already professionals with your own channels on YouTube, but I'm not. Very much a beginner. So, what we're going to be looking at today in this lesson is, or are, angles in a quadrilateral. That's not a 2 or a Z, by the way, that's just a little squiggle. How's that? Is that better? Alright, let me just show you what I've got so you can have the same around your house. So I've got some sort of whiteboard or scrap paper that you could use, ruler, because we all know we like to use rulers, lots of sorts of different coloured pens, and then I've got this as well, a vocab book, which is any sort of interesting vocab that I'm going to go over. You could just add it to your book as you go along as well, if you can have one of them as well. Also, I've got a little drill, you know, just in case things go way out of hand. Right, so what we're looking at today then are angles in a quadrilateral. So we're going to look at some sort of vocabulary straight away. First of all, what is a quadrilateral? And I might say the word polygon in there as well if I write that one down for you. In a polygon. Now we need to work out what those words mean. Quadrilateral and a polygon, we might have already heard them in our maths lesson. Straight away, boom! I've got them down in my book. It's almost as if I've planned it. So, quadrilateral, we can then just say, forget that pen, let's go for colours. A quadrilateral, we can nice and easy say it's just a four-sided shape. Okay, nice and easy to remember. Quad, meaning four in there, quad bike, your 4 wheels, so that's something you can try and link to. And then a polygon, you might have heard this before, you might not. It's, I'm trying to think, there was a Pokemon that was to be called something like that as well. Google that. So a polygon is a shape with straight sides. Let's go for a different coloured pen. I've only got brown, grim. So it's a shape with straight sides. Okay, that's just to stop people whenever you sort of do like problems in your SATs test to do with how many angles are in a particular shape. That's just to stop people saying drawing a shape like, I can get rid of that now, I've already said hi. Drawing a shape like that and saying, well, how many angles are in that? Well, there's not really any angles in there. So we just say polygon. Okay, you might hear that word in your SATs, polygon. So straight away, my first question for you to think about then is, if I was to draw any quadrilateral, any 4-sided polygon, how many angles are going to be in it? So there is one quadrilateral, here is another. We can draw something like this as well. So all 4-sided shapes. The most favourite is a square. We've then got a rectangle as well, all 4-sided shapes. And how many angles are in them? Well, let's take the most favourite of all quadrilaterals, a nice humble square. There we go. Now, I did say I've got a ruler, so I'm going to start with a ruler from now on. So if we look at these angles, in a SATs test you will get shown these angles like that. And we could say, what does that show us? Well, we now know that that equals a right angle. And how many angles are in a right angle? We know there are 90 degrees in a right angle as well. So these are facts that I already know. I can always go back to the facts that I know. So if I've got 4 right angles in a square, what I could then draw are one right angle. Okay, that's 90 degrees. Another right angle, which is another 90 degrees. And we know there we've got a straight line. Well, I know that 90 degrees add 90 degrees, and our straight line is 180 degrees. Well, actually, I've got that again then, haven't I? Because I've got 4 right angles in a square. So I've got 180, add 180, which then equals 360 degrees. Okay, 0 to 0 is 0. Look at my 10's got 8 at 8, which is 16 tens. 100, 100, another 100, 300's there, so 360 degrees. Well, that's how many were in a square. Now I'm going to tell you a little fact that we can remember. If this is my... Come on, Mr. Barker, use your ruler. Got to live by example. If I was to then to draw any square, or any... There, we've got the 4 right angles, then I will know that they are 360 degrees in any square. So I know Mr. Barker's now going to tell me that in any quadrilateral, however I draw it with a ruler, so there's one quadrilateral, there's another quadrilateral, another line, I've got 360 degrees in any quadrilateral as well. We could always refer back to the humble square, and how many degrees are in the humble square? I know 360, so there's going to be 360 in any quadrilateral. That's something that we learnt last week. It's just a quick reminder now for you. Okay, so if that's the case, then let's have a look at some problems we might get asked in our SATs test. Let's use a different colour, just, you know, to jazz things up a bit. So I draw a shape like this. So we've got a shape like that, and I get asked in a SATs test that if I put that down at it's an acute angle, so it's going to be less than 90, so that's going to be 60, I could do it at 65 degrees. Okay, I might get asked how many degrees are there in angle A. Okay, so I refer back to what I always know, my facts that I always know. I know that there are 360 degrees in any quadrilateral. Mr. Barker taught me that a few weeks ago. Okay, what else do I know about this shape? Well, I know there's 65 degrees over in this angle. Do I know what these are? Yes, I do. They haven't told me that there's 90 degrees, but I know that in a right angle there's going to be 90 degrees. So I can label it 90 degrees there and 90 degrees there. Okay, so if I show you how I work this one out, I'll set you a problem to do yourself. So I've got 90 add 90. Well, I know that's like a straight line, so I know it's going to be 180. Or I can think of it as 9 add 9, which is 18, and then make it 10 times bigger, so 180. Okay, so I know I've got 180 degrees there. I know I've got 65 over here. Okay, I know my hole is 360 degrees. And I know 3 parts of my whole. Well, if I add them all together, so 0 add 5 is 5. Look at my tens, 8 tens is 6 tens. Well, I know 6 add 6 is 12. So add 2 more, 12, 13, 14. So 14 tens. And then 100, I've got 100, add another 100, that's 200 there. So I'm looking at 245 degrees as my part, as a big chunk of my part. Well, I know then that my hole was 360. So 360, if I take away my big chunk of what I already know, I've then got 245 there. I'm going to take that away. 0 ones take away 5 ones. If I've got 0 ones, I can't take 5 away, so then I'm going to have to then rename. I'm going to rename one of these tens as 10 ones. So now I can do 10 ones take away 5 ones, which is 5. 5 tens take away 4 tens, which is 110. And then 300 take away 200, which is 100. So then I've then been left, I've taken away that part, I've then been left with 115 degrees. So then A would then be 115 degrees. I know if I look at the type of angle, it's obtuse, and I know that's over 90 degrees, but not over 180. So I should be right. I then could check. How could I check? I could use the inverse operation. I could add all 4 corners together, and I should end up with 360 degrees. Okay, so if I give you a problem now, if I rub all these out, it's going to be very similar to the problem that we've just worked out. See if you're listening. Right, that's my shape. My question is, how many angles are there? How many degrees are there in angle A? And if I give you that piece of information, you should now be able to work out A. So if you pause the video, do exactly what I just did and work out A. Right, so now I'm going to go through the problem. So we've got 90 and 90 again, which is 180 degrees. We had the 57, so just like last time, if I add up all my parts, I then get my big part. So that'll be 7, 8 tens add 5 tens, well 5 add 5 is 10, add 3 more, so it'll be 13 tens, 100 add 100 is 200, so 237 degrees is what we're looking at there. So then 360, take away degrees, take away 237, I should then be left with the remaining part to my hole. So again, I can't do 0, 1 to take away 7, so I'm going to rename one of my 10s. There's 10 ones, 10 take away 7 is 3, 5 tens take away 3 tens is 2 tens, and then 300 take away 200 is 100. So I've got 123 degrees. Hopefully you got the same there as well. Okay, another pause point for you. So, what, that clean. Instead of now looking at a shape with 2 right angles, I'm now going to look at a shape with completely different angles on there. So it's got to still be a quadrilateral. It's got to still be a polygon, straight-sided. So I've got that sort of shape there. I could start labelling this up for you. Now I know that is more than a right angle, so that's got to be, let's say that's 97 degrees. This one over here is less than a right angle, so I'm going to call that 35 degrees. And then I'm going to give you this one as well. So let's go that is, well, it's less than, so let's just say that's 80 degrees. So what then is angle A? Pause the video again and then we'll go through the answer together. Okay, so just like before, I'm going to add up my 3 parts, take it away from the hole. What do I know the hole? Oh, I know it's a 4-sided shape, so it's 360 degrees, and then I should end up with A. So let's do that together. Start with your biggest number, so 97, add 80, add 35. Now some of you might be able to do part of this already in your head, because you could quite easily add 80 and 35 in your head and add it on to 97. Let's just do it step by step. So 7 ones add 5 ones. I know 5 add 5 is 10. Add 2 more will be 12 ones. Right, so I've got quite a few numbers here to add up. So 9 add 8. Well, I know 2 8s is 16. Add 1 more is 17. Add 3 then will be 20 tens. Add 1 more will be 21 tens. Okay, so that is all 3 parts. Okay, take that away from my hole. I know my hole is 360 degrees. Take away 212 degrees. Again, can't do 0, take away 2, so I'm going to rename. And 1 10 into 10 ones, 10 take away 2 will be 8. 5 tens take away 1 10 will be 4 tens, and then finally 300 take away 200 should be 100. So this bit you should have got at 148 degrees. Okay, now just before the end of this lesson, there's something interesting about some quadrilaterals. Okay, so if I look at a parallelogram, which is, as we know, it's just a rectangle but lopsided. That's one way of thinking about it. Okay, I've drawn that a bit skeevish actually. There we go. There's something interesting about these angles. So I know that that's obtuse, I know that's obtuse, and actually I'm going to use a different colour. I know that's acute, and I know that's acute. What I know about those types of angles is that they will equal each other. So I can call that one A, and I could call that one A, and I could call that one B, and I could call that one B, because I know that they actually add up to each other. Okay, so in fact, if I wanted to work out the angles in this quadrilateral here, if I get asked this in my test and I get told that angle, so let's say that angle is 110 degrees, I've got to then think back to the facts that I already know. I already know that everything adds up to 360. I know that this angle and that angle, the opposite angles, are the same. So I know that that equals 110 as well. So now all I've got to do is try and work out what these 2 angles are, and I know they're going to be exactly the same. Well, my whole thing again, what was my whole thing? It was 360 degrees. I already know a big part of that. I know a big part of my hole is 220 degrees, because what I've done there is add up both these red angles. Okay, so if I take them away, 0 take away 0 is 0, 6 tens take away 2 tens, 4 tens, and 300 take away 200 are 100. I've got 140 degrees left, but I've got two angles. I know they're both exactly the same. So with these degrees, what I can do is share them equally between the two angles, or divide them by 2. So I've got 140 degrees, and I'm sharing those amounts of degrees equally between those two angles. So I'm dividing them by 2 because I know they're the same. So 2's into my 1, I can't do. Carry that over. 2's into 14, I know are 7 because I know 7 times 2 equals 14. And 2's into 0 will be 0. So I know then that each one of those angles will be 70 degrees. Okay, so just to recap, I knew this angle was 110. I knew then that the opposite angle was 110. I added them together to get a big part, and I took them away from my whole, which then was 140 degrees, and then divided that equally between the two angles, and then I got 70 degrees for each angle. So if that's the case, have a go at this problem. So instead of 110 now, I'm going to tell you that these are 123 degrees. That's 123 degrees. So what would angle A be, and what would angles B be? If you pause the video and have a go. So just like before, I know that that is 123 because they're opposites, so I know they're the same. If I add them together, I know I'm going to end up with 246 degrees. I know my whole was 360 degrees. So if I take away that part, I know I'd end up with 414 degrees. And then I've got to divide that 114 degrees between the two remaining angles because I know they're exactly the same. So I know that I will end up with, that's right, let me trick myself there, 57 degrees. Okay, so if you know that, in the comments on Class Dojo, not Class Dojo, sorry, Google Classroom, see if you can work out what A, B, C and D equal. C equals D equals, if I'm telling you that this angle here is, let's pick 157. Okay, good luck, and I shall be seeing you later.